Greetings and welcome, friends, on this fine, fine day. Hey, you've seen this before. This seems vaguely familiar, and no, this is not a glitch in the Matrix. This is not deja vu. You've seen this pattern before, but backwards, right? Back in the day, we had the sum and difference pattern, right, in which we said a plus b times a minus b, and we said, hey, those aren't quite the same, but they're not quite opposites. Those were called conjugates, and we said that when I multiply that out, when I FOIL that out, is equal to a squared minus b squared, and the sum and difference pattern was something that allowed us to do a little shortcut to find the answer when multiplying these two binomials. Today we're going to do the same thing backwards. Instead of multiplying them, I've flipped the formula around. Nintendo Switch coming out right later on. Don't you worry. What is it? March 2017? I don't know. I switched it around because instead of multiplying, we're going to use it for. I was going to say evil, but no, we're going to use it to factor. Right? Here we go. We're going to use it to factor. And technically, these problems are factorable using your current strategies. The only benefit here is that this will make you a factor ninja, where you will be able to factor problems super quick without having to do all of the work. Let's see. So here's example 1. All right, like so. I'm tempted to show. No, we'll do this. We'll do this the right way. We might not have enough time anyway to do it the wrong way or the long way. Not wrong, right? Just longer. So between this, I look at this and I suspect that this matches that pattern, right? If I'm looking here, right, I'm seeing some similarities between these two. All right. My first similarity I notice is this only has 2 terms. 1, 2. That has 2 terms. 1, 2. Okay, so that's the first similarity. The second thing I notice is that this is called the difference of 2 squares pattern. They're talking about, right, things that are squared. And notice this is a perfect square. X squared is a squared number. And 25 is a perfect square. So it seems to match the pattern all around, and now my question for you is, if it matches that pattern, what would A have been, and what would B have been? Well, A is whatever was squared that gave me the first term, and so what squared would equal X squared? What squared would equal X squared? Yes, this question is simpler. Don't be scared of how simple it is. What squared would equal X squared? What's in the spot of A here? The plain old X here. If I square X, I would get X squared. And then for B, my question is, I know that B squared is equal to 25. I'm ignoring the sign for now, okay? B squared equals 25, so what must B have been that squaring it would give me 25? Yeah, 5. Yep, 5 squared. So A is X, B is 5, and since it matches the pattern, I can just say A plus B, A minus B. So that's going to be X plus 5, X minus 5. And I don't even have to care about this sign. The only thing I have to care about is that it's a minus sign, because this is the difference of 2 squares pattern. Difference of 2 squares. Only a minus sign there. And just so you're aware, there is no such thing as the sum of 2 squares pattern. Does not exist. D-N-E. So look how fast I was able to factor that. Ba-da-ba-ba. Right? Super fast. Super fast. All right, let's look at this next one. Now the question is, what is A and what is B? Now in this case, I want to think about what squared, right, minus what squared. So what thing squared gives me 4? What squared is 4? What are our thoughts? 2, right? And you don't have to write this middle step here. I'm just trying to use it for us to imagine. Right? 2 squared is 4, so a is 2. And then what squared is z squared? Must have been z. Yeah, so a is equal to 2z. And what squared is equal to 1? 1 times 1 is 1, so b is equal to 1. And watch this. This is just going to now plug it in for a plus b, a minus b. So a is 2z plus b, which is 1, times a minus b. So 2z minus 1. Factored. Done. 1 and done. Now, I want to show you, you don't have to write this down. This is our old way of doing this problem. X squared minus 25. I don't think I even gave you space to write this down. If I was to have to factor this the old way, I would have written this as x squared plus 0x minus 25. The leading coefficient is 1, so I don't have to do the AC method. I would have found the factors of 25 are 1 and 25, 5 and 5, and I would have asked which of those subtracted to be 0, right? And I would have said, oh, 5 and 5. And then I would have asked, okay, so I'm going to have an x with a 5 and an x with a 5. And their signs are going to be different because they multiply to be negative, right? They're either plus minus or minus plus. And they add to be 0, which either of those combinations will work. So I'm going to end up with an x plus 5 and minus 5. And I'd get the same exact answer, but with a whole lot more thinking. Okay? A whole lot more thinking. And also, it's weird, the idea of having to pretend that there was a 0x in the middle of those two things the whole time, right? It's just kind of weird. So the benefit of the pattern is speed. And mathematicians, my friends, are efficiently lazy people. That's right, you heard it. Efficiently lazy people. We like to get the right answer quickly with minimum work. That's a valuable objective. It allows me to do more math later, right? So here we go. Let's cruise through these, all right? So these, first of all, I notice, have a minus sign. They're differences, okay? Minus sign. They also have 2 terms, okay? So that makes me suspicious. Hey, maybe there's a difference of squares pattern here. And then lastly, I notice, wait a minute, this x squared is a perfect square. 36 is a perfect square, right? Something squared is equal to 36. And so these match the pattern. So I'm going to say a would equal x here. B would equal the square root of 36 is the way I could ask that. Or I could say what squared is 36? And it's 6, yeah. So this is going to be x plus 6, x minus 6. Done. Speedy Gonzalez. Gonzalez? Probably. Who cares? I don't know. He's a andale arriba, I don't know, something. All right, difference, perfect squares, yes. A, that's weird that this is backwards, all right? I think you guys agree, that's weird, but don't worry about it, that's fine. A equals, what is the square root of 100? Or what squared is 100? What times itself is 100? 10. And what times itself is m squared? And so a plus b, a minus b. Super fast, right? Awesomeness. Okay, these problems getting a little trickier. Here we go. A, all right, 9n squared. What squared is equal to 9? 3. And what squared is n squared? N. All right, let's see. How about 16? What squared is 16? Right, 4 times 4. Squaring is multiplying by itself. Which actually, tell you what, let's all write down a list of the perfect squares. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. I forget I usually do this, and then I forgot to do it today. 5 times 5 is 25. 6 times 6 is 36. 7 times 7, 49. 8 times 8, 64. 9 times nuevo, 81. And 10 times 10 is 100. And 11 is 121. Ooh, sneeze. That was a good one. Thank you. 121 is 11 squared. 12 squared is 144. 169 is 13, etc. And there are infinitely many perfect squares. All right, those are numbers that were the square of another number, an integer specifically. All right, so here's my A and the B. So I'm going to have A plus B times A minus B. Right? Formulas are fast. Formulas are fast. Imagine if I asked you on last night's homework to factor 9n squared plus 0n minus 16. You would have had to find AC. You would have split the B term. You would have yoink from the first two to the last two. You would have found those things in the parentheses. You would have then written your answer. And all of that work would have brought you to exactly the same thing. Right? And like, that's a lot. Like that, this problem is like a 4-minute problem, and we just did it super fast. We did it faster than 4 minutes, and we wrote a list of perfect squares in the same time. What? What? Yeah, in your face problem. We know your tricks. We will break you down and destroy you using our ninja math factoring skills. All right, here we go. Question 4. It's a minus sign. It's got 2 terms. It seems to match the pattern. What is A? What is B? Someone want to help me out? Yeah, 4H. I like it. I like it. And the pattern, right? Patterns are nice, friends. Our human minds are good at pattern recognition, even better than robots. Although with neural networks, they're getting there. They're doing pretty good. But yeah, we recognize a pattern. I use the pattern, and then we become awesome at it. It's great. Okay, let's see. These are problems not found in the book. These are Waddy exclusives. Wow, you'll only see these problems here. Actually, I lied. There are a finite number of small perfect squares. Right. But here you go. So these problems probably are all over the place. But we can still pretend we're special. All right, if I want to solve... All right, what did I do when I wanted to solve a quadratic? I set it equal to 0, step 1. I factored it, and then I set the factors equal to 0. Okay? So, this is set equal to 0. Now the question is, can I factor this? Yes. And it turns out, wait a minute, I'm suspicious. These look like perfect squares to me, and it looks like there's a difference of them. So, let's use the pattern. A is equal to x. B is equal to who now? What are our thoughts? What's the square root of 16? 4. All right. And so I'm going to have x plus 4 times x minus 4. And don't forget r equals 0 still here. And then according to zero product property, 2 things multiply to be 0, therefore one of them must equal 0. And let's see, let's alley-oop it to our past selves. How do I solve those equations? All right, subtract 4 from both sides, and then this one I would have added 4 to both sides. And I get x equals negative 4 and x equals positive 4. Bam. All right, so it's not too scary. And man, this factoring is so fast. Eventually, you guys will just spot these. It'll be awesome. Awesome. All right, this second part. I can't factor it as is. What do I need to do first? What was special? Yeah, set it equal to 0. So let's move that 9 to the other side. We'll have 25x squared minus 9 equals 0. And hey, I think these are perfect squares. And there's a minus sign. I think it's a pattern. So A is equal to what? Well, let's see. What's the square root of 25? Yep. And then I've got the x. And the b is going to be what? The square root of 9 is 3, because 3 squared is 9. And let's see. So a plus b times a minus b is equal to 0. Plug it in the pattern so fast. Oh, guys, you're going to be experts at this. I can't wait. You're going to probably be able to get your homework done before you even leave school today, I bet. You'll do it during lunch. You'll be so excited about it. So let's see. Oh, wait, what am I doing? I was going to say A and B again. I'm crazy. All right, these two things multiply to be 0. Break it up. So either 5x plus 3 equals 0 or 5x minus 3 equals 0. So subtract 3. How do I get x by itself here? Yeah, inverse operation. Man, are you guys feeling it yet? Like, are you like, man, the stuff that was at the beginning of the school year, it was tough at the time, but like it's starting to become familiar to you, I hope. All right. Add 3 to both sides over here. We've learned a lot this year, lots. Yeah, that's true. But I think I'm getting better at teaching it, maybe. I don't know. My first principal told me, you don't know something until you've taught it 3 times. I thought was an interesting idea, which is actually a value in you guys working as partners and trying to explain something verbally. Your brain is going through the process of sorting information and then finding ways to express it with words. It's actually, yeah, being able to communicate something to someone else is a super great way to solidify your understanding of it. Yeah. All right, and then last problems. Last problems. What's the problem with these problems? Huh. There's a difference. Yeah, and that number, the problem with it is that it's not a perfect square, right? Like this problem, 25, I'm fine with that because that's a perfect square, right? I can say 5 squared is 25. But these problems don't have that. But these problems do have a common factor. Yoink, yoink. Turns out I can steal that 3 from both of those. Watch this. So 3 times. Actually, you guys tell me. We need practice on this. I'm going to have our internet friend. And Micaiah, what do you notice about those values inside your parentheses? Let's see, I'm back, internet friends. So we had x squared minus 25. Do I like these numbers better, Micaiah? Yeah, I think those are perfect squares. What would a have been for this one? What numbers, ignoring this 3, what squared would equal x squared? Well, the 1 part, yeah. But I need the x. And then what would equal 25? What squared is 25? 5. So this 3 is still out front. Don't forget it. And I'm going to use the pattern. What is my pattern? A plus... Yeah, a plus b, a minus b. So x plus 5, x minus 5 factored. So this one, the only tricky part was I had to steal something first, and then the inside was factorable using my pattern. Does anyone know what I could steal from the second one, this last problem we're doing today? Because I can't steal a 12. That doesn't fit into the 27. Smaller than that. A 3. Man, I guess I'm not very creative. I just keep stealing 3s all day. It's like if I was the Hamburglar, I would be like the 3 burglar, maybe? I think so. Let's see, 3 times what number is 12? Dwayne the Rock Johnson? Interesting, interesting. Oh, I missed my squared here. So, ladies and gentlemen, we just factored. I factored out the 3, and what was left inside were 2 perfect squares. Right, 4 is a perfect square, 9 is a perfect square, x squared is a perfect square, and they were being subtracted. And so a would have been 2x, and b would have been 3, and then a plus b, a minus b. That's all I do. So that's the pattern we learned today. Next lesson, in the same section, we're going to look at a different pattern, similar themes, and it's a little bit trickier. But if you can learn these patterns, you get so fast at factoring. It's amazing. All right, thanks for watching, Internet friends. Bye-bye.